Next question, question number 8 in exercise 1.1, that is the last question. Given there are three amounts invested in bond, the total amount invested is 5,000, and then the income from the each bond is mentioned as the first bond 6%, second bond 7%, and third bond 8%. Calculating the interest, simple interest for the each bond, 6% of X, 7% of Y and 8% of Z totally yields the interest at 358. Then 6% of X means 6 by 100X. That means 6% here all are annually is given. Therefore, N is taken as 1. In this case, yes, simple interest is equal to PNR by 100. P means X, N is 1 year, rate is 6%. Totally that is equal to 6% of X, that will be equal to 6 by 100X. 6 by 100 into X. That is written here. In the same case, 7% of Y, 7% of Y, then 7 by 100 into X. Here also N equal to 1. And here 8% of Z, N is 1, then 8 by 100. The total interest value will be equal to 358. Now all are have 100 as denominator, then cross multiply it. Now here we have 6x plus 7y plus 8z equal to 35,800, or multiply by 100, you will get this equation. This is second equation. And the third case, given that the amount invested in the first two bonds will be equal to 70 more plus the third bond is given. For that, 6% of X plus 7% of Y will be equal to the 8% of Z, the value of 8% of Z plus 70. That is mentioned in the question itself. And then simplifying these by the above method, we'll get 6x by 100 plus 7y by 100 minus 8z by 100 equal to 70. Multiply by 100, you will get another equation, third equation as 6x plus 7y minus 8z equal to 7,000. We formed three different equations now. This is the system of three equations. We should solve by rank method. For that, write in matrix equation. To write matrix equation, first write the quotient matrix. The quotient of the first equation 1, 1, 1. So 1, 1, 1 taken here. The quotient of the second matrix 6, 7, 8. So 6, 7, 8 is taken. And the quotient of the third equation 6, 7, minus 8, 6, 7, minus 8. The second is always the variable matrix x, y, z, and the right side we have constant matrix. The first equation has constant 5,000. The second equation we have constant 35,800. The third equation we have constant 7,000. So this is the respective matrix equation. Now we should form a augmented matrix. Augmented matrix. This is in the form of Ax is equal to B. So augmented matrix AB equal to augmented matrix AB, that will be equal to 1, 1, 1, 5,000. Second one 6, 7, 8, 35,800. Therefore, the augmented matrix is AB 1, 1, 1, 5,000, 6, 7, 8, 35,800, 6, 7, minus 8, 7,000. Now, we should reduce by using elementary transformation. Now, to make this 6 as 0, multiply R1 by 6 and subtract. R3 tends to R3 minus 6 R1. In this case, we have R3 as 6, 7, minus 8, 7,000, and 6 R1, multiply R1 by 6, 6, 6, 6, 30,000. Subtract 0, 1, minus 14, 23,000. 0, 1, minus 14, 23,000. The second iteration, again here we have 6. So R2 tends to R2 minus, again multiply R1 by 6 R1. That will be equal to R2 6, 7, 8, 35,800. Then R1 multiply R1 by 6, 30,000. Subtracting, we have 0, 1, 2, here 5,800. Right in the second row, 0, 1, 2, 5,800. There is no change in the first row. You can write as it is given in the question, 5,000. Now, we should make this 1 as 0. Then we will get a equivalent form. Both entries are 1, so directly we can subtract it. R3 tends to, the new R3 formed by using the previous equivalent matrix R3 and R2 by R3 tends to R3 minus R2. Just subtract these two. I am not choosing R1 here because these two entries are 0, while we subtract the remains the same. For that purpose I am choosing these two to bring this element as 0, and also this one is also 1. 1 minus 1 becomes 0. So R3, new R3 formed here by using above R3 and R2 by subtracting R3 minus R2. So 0 minus 0, 0, 1 minus 1, 0, minus 14 minus 2, then minus 16, then 23,000 minus 5,800. 23,000 minus 5,800. We have 23 minus 28,000. You can write here R3 0, 1 minus 14, 23,000. And then R2 0, 1, 2, 5,800. Here we have minus 23,000. Sorry. Then now subtract minus 0, 0, minus 16 and minus 23,000 and minus 5,800. Then which implies totally we have minus 28,800. We can have 28,800. Now, minus 28,800, therefore the last row, third row becomes 0, 0, minus 16, minus 28,800. And then our next priority to bring this one as 0. We can subtract R2 and R1, we can get 0, but in the same time, if we make this one is 0, this become non-zero, so just to stop the process. So 0, 1, 2, 5,800. There is no change in the second row and there is no change in the first row also. 1, 1, 5,000. Here we have a final equivalent matrix. In this we have formed a equivalent form, and then this last equivalent matrix contains 3 non-zero rows, and rank of A is equal to, we have 3 non-zero rows, 3, and rank of AB is also equal to 3. Therefore, rank of A equal to rank of AB equal to 3, equal to number of unknowns, Therefore, system is consistent and has unique solution. To find this unique solution, again we reform this equivalent matrix into matrix form again. The corresponding matrix form of the last equivalent matrix is coefficient matrix 1, 1, 1, 0, 1, 2, 0, 0, minus 16 into xyz, which is equal to the constant matrix 5000, 5800 and minus 28,800, which implies there are three equations. The first one is x plus y plus z equal to 5000. The second equation is 0x plus 1y, so 0 omitted, so 1y plus 2z equal to 5800. The third equation is 0x plus 0y, so both x and y omitted, minus 16z equal to minus 28,800, which implies z equal to 28,800 divided by 16. Which is equal to 1800. Divide by your calculator, which will be equal to 1800. Now z equal to 1800. Substitute z in equation 2. This is equation 1. This is another one, equation 2. This is the third equation. From third equation we get z equal to 1800. Substituting in second equation, y plus 2 into 1800, 3600 equal to 5800. Then subtracting y equal to 5800 minus 3600, which is equal to 5800 minus 3600, which is equal to 2200. So y equal to 2200. And x, substituting in 1 implies, substituting the values of y and z in 1, we have x plus y plus z equal to 5000 here. So x remains same, x plus then y plus z, adding the values of y and z, we have 2, 3, 4000, 4000, x plus 4000 equal to 5000. Equation 1 implies x plus y plus z to 5000. Substituting y and z, 1800, 2200, x plus these two implies 4000. So x plus 4000 equal to 5000, which implies x is equal to 1000. Therefore, the solution is x comma y comma z equal to, therefore the solution x, y, z equal to, or the amount invested in each bond. Therefore, amount invested in each bond is 1000, 2200, 1800.